Welcome to this explainer. Today we're going to unpack something that is absolutely transforming the AI landscape, the Model Context Protocol, or MCP. We are going to look at how MCP is actively becoming the definitive, universal standard for AI tool communication. I mean, if you've been building or working with AI agents lately, you know the struggle, right? Trying to get them to reliably talk to the outside world is tough. So let's map out exactly how standardized protocols are completely eliminating the need to write custom integrations for every single data source.
Okay, let's dive right in by confronting a pain point that, honestly, vibe coders know all too well right now. We call it the N times M integration crisis. Think about it. The exhausting, brittle process of writing custom integrations for literally every new AI model and then every new tool you want to use. It is a massive roadblock to scaling AI.
So here's our roadmap for today. We'll cover 1. The integration crisis. 2. MCP, the universal socket. 3. MCP first agent skills. 4. The vibe coder's workflow. 5. Building your MCP server. And finally, 6. Security and best practices.
All right, kicking things off with Section 1, the integration crisis.
Let's look at the math here, because it's genuinely terrifying if you're a developer. Say you're experimenting with 5 different language models, and you want to connect them to 10 different external tools, like Jira, BigQuery, GitHub, Google Drive, whatever. Traditional ad hoc development means you have to write custom integration code for every single intersection. That is 50 bespoke, fragile JSON parsers and integration points you have to maintain. And you know what happens next? Just one tool API changes and multiple parser loops break. It's an absolute maintenance nightmare that traps you in low-leverage work.
But what a relief it is to look at the alternative. When we adopt a standardized interoperability layer, that whole mess shrinks down to a clean, manageable linear scale, big O of n plus m. You just build one side of the bridge, and the protocol handles the rest.
Which brings us to Section 2, MCP, the universal socket.
This hardware metaphor really hits the nail on the head. Think of MCP as the universal plug. It's the USB-C for AI tools. Remember when we used to need a different power cable for every single electronic device? We don't do that anymore. And MCP does the exact same thing for the AI factory floor. It allows agents to instantly connect to external systems without having to understand all the messy underlying networking nuances or payload disparities.
Now, to make this USB-C connection actually function, MCP relies on standard transports. By standardizing these definitions, you can plug tools directly into your agent's harness without writing a single line of integration code. You're typically going to use one of 2 transports. First, there's Studio, or Standard Input/Output. This one is perfect for local prototyping because your host client just launches the MCP server as a local background process. No complex network setup needed at all. Second, you've got SSE, or Server-Sent Events over HTTP. This connects to remote endpoints and streams data in real time. Because it has a smaller footprint and fewer dependencies, it's really the ideal choice for deployed agentic applications.
Moving right along to Section 3, MCP versus agent skills.
People get confused about this, so it's fascinating to see the clear boundary drawn here. They don't compete, they compose. MCP provides the reach. It's the hands and the wiring, physically connecting the agent to external databases or APIs. Agent skills, on the other hand, are the know-how. They act as the playbook, teaching the agent the actual conditional logic and the rules for a specific task. So when an agent skill needs real-world data to execute its playbook, it simply tells the agent to call an MCP server to reach out and grab that data. The playbook and the hands, working together perfectly.
Let's look at how this changes things in Section 4, the vibe coder's workflow.
Because we're replacing that bespoke hardwiring with a standardized socket, setting up your coding agent becomes incredibly straightforward. For vibe coders, it's all about consumption over creation, hooking into registries instantly. And it really just comes down to 3 standardized steps. Let's map out exactly how progressive this is. Step 1 is discovery. You just locate pre-built servers from public registries, third-party managed servers like the official Google ones for BigQuery, or your own internal enterprise registries. Step 2 is configuration. You check your prerequisites, define the scope of what it can access, and securely handle your authentication. And finally, connection. The host client performs a basic handshake with the server. It lists out the available tools, validates the output schema, and boom, your agent is connected and ready to pull data.
But what if you need a custom tool? That's Section 5, building your MCP server.
So even if the tool you need doesn't exist yet, you really don't need a massive enterprise team to build it.
You can actually write a fully functional SQL MCP server in about 40 lines of Python. Seriously, this simple architecture basically has 3 parts. First, you initialize the server and connect your local database. Then, use a decorator like @server.listTools to expose specific capabilities, say a query_knowledge tool, and define the required JSON schema. Finally, @server.callTool holds the execution logic to actually run the SQL query and return the text content safely back to the agent. It's elegant and it's incredibly fast to prototype.
Now, let's be real, things will occasionally go wrong. But here's a pro tip. When an agent hallucinates parameters or fails to parse a payload, don't just blindly modify your system instructions, debug the actual transport pipes. You can use the MCP inspector, which is this great native developer tool with a local web panel, to manually test tool schemas and inspect the raw JSON RPC 2.0 packets. Or, if you're using an SSE connection, Chrome DevTools is absolutely perfect for tracing those incoming web streams. Fix the pipe, not just the prompt.
Which naturally leads us to our final part, Section 6, Security and Best Practices. With this kind of unprecedented ease of access, we absolutely must implement necessary security guardrails. This is a critical warning directly from the source material. Runs everywhere quickly becomes runs safely nowhere. You should never blindly attach unvetted open source capabilities to an autonomous agent that has access to your local file system or your credentials.
Because these agents operate autonomously, they are uniquely vulnerable to something known as MCP spoofing. This is a very real threat vector where a forged or compromised server poses as a legitimate tool. If your agent connects to it, that rogue server can inject malicious payloads or demand excessive privileges. And since the agent is running its loop autonomously, it might just execute those malicious commands before you, the human, ever have a chance to intervene.
To prevent that, we have to follow strict best practices. First, always audit the code of public servers before connecting them. Second, scope your projects tightly. Limit an MCP server's access strictly to the resources it needs for that one specific project. And finally, my favorite architectural pattern, use RAG for tools. You dynamically load tools into the registry only when they're actually needed, and then drop them when the task is done. Treating tool access like retrieval-augmented generation not only boosts your security by minimizing active connections, but it also prevents attention dilution and context rot within your model's context window. It's a win-win.
By adopting the Model Context Protocol, you elevate yourself from merely wiring fragile APIs to orchestrating a highly scalable, robust AI ecosystem. So I want to leave you with this final, provocative thought to chew on. As AI transitions from isolated mechanics to a global, autonomous workforce, are your tools ready to speak the universal language? Thank you so much for joining me on this explainer. Get out there, try building your own MCP server, and I'll see you in the next one.